walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to Taiwan. I've been all around the globe, trying to protect your soul. We are heroes tonight. We will fly above the sky. We are heroes tonight. Yeah. We are heroes tonight. We will fly above the sky. We are heroes tonight. Feeling like a dynamite, ready to explode right up in the sky. I need you to listen, I need you to hear, and don't show any fear. I've been flying from town to town, from London to Taiwan. I've been all around the globe, trying to protect your soul. We are heroes tonight. We will fly above the sky.
So this was the whole day around my sessions, my gym session. So like today I started my day with like the gym, like abdomen gym, and I hit the chest workout. I hit it was quite overweight. After a long time I started pushing my limits to the weights, and in coming time I will set my challenges, like what I need to complete in the given time frame, like in 1 month and 2 months, how much I should able to lift the weights and how much progress I can make. So I will keep this challenge in my coming weeks, but right now my main challenge is to get consistent. So right now it's 12:04 in the in the night. So in the morning I finish my workout, and then I just get back on my desk just to prepare topic for the deep learning. And just for the deep learning, because right now into the data science of 2 batches I have the same topic, and the same topic I have into the GenAI. So therefore I was preparing best way possible to create content on the deep learning for the students, and it done, and I make on the ANN, which was artificial neural network. Like last video I tried, but it was completely, we can say, like with lot of background noises, and even it was not explained very well. So today I just try to explain with the simplest way, like how it works, just with the quick way possible, like if I able to make it. So it is basically we are working on the feed forward network, which thing I'm just going to explain in my class. The same I'm going to explain here in order to get for the theoretical. So here we have let me just try to draw a diagram. So so let me just draw some diagram. So this is the neuron we have, and it is going for the forward, and here we have the activation function, and here it is providing the output layer. So here we basically add the sigmoid, right? So what happened here? So we have x1, x2 and x3. Suppose these are my features, and I am just going to train those data. So here our model will add the random weights, which are w1, w2 and w3, and here it gets summation of the weights and the x. So what it look like, it is like x1, we can say x1 multiplied w1 plus we can say x2 multiply w2 plus x3 multiply w2, and this is basically I can say it is y equal to, and in the short term we can say as w transpose x. So whatever summation we are making, and we are getting y as we got here. So we're making summation of all the things and passing into one activation function. So here we can say it is an activation function. So we have basically popular the 4 activation functions. It look like how it look like if I show you here. Like suppose we have first ReLU. So here the input we are passing from the first input layer, so it is coming, we can say, as y, or how I can say the summation, we can say like it is for the w transpose x, right? So what is that? So we are talking about this summation, like we are doing x, so the inputs multiply with the weights, and then we adding the bias. So this we are getting here, we can say it is y. So we are applying an activation function. So it is basically activating the neurons and started learning, like it will start learning the patterns. Now if we go here to here, so first we have a ReLU. So what ReLU says, it is basically saying it is max, it's taking like 0 comma, we can go for the y. What it means, suppose if we did a summation, if we do the calculation of what, the calculation of these units, this inputs and the weights, right, and the bias, like the thing which we have did here, like in this area, this summation which we get, and in the end after summation, if we getting the value, like suppose as 0.40, this whole summation, if it getting positive which is greater than 0, you are keeping so up, so you just need to keep as y. Means suppose if you're getting y equal to 0.40, you can pass it as it is for the next layer as a 40. So you can say this calculation is saying 0.40. So this work done, this work done. So now it will go for the next layer where we have w4. Again it will be get multiply with this output layer 1, and then it will add a bias, and after calculation it will go for to the next layer. So this is the first activation function, is that ReLU. Then we have like here, if we getting a negative value, so definitely because of 0, so here if we add, like apart from 0.40, if we add just 0, it is making the computation completely 0. Like plus b, if you see, if we are passing 0 with the multiplication, for sure we will getting output for the 0. So this will this will cause a vanishing gradient problem. So here you are not sharing and learning the patterns and providing the 0 input, and you are not providing the meaningful inputs for the output layer. Therefore we should not use the ReLU if we have negative values inside our data, and like so it can be awkward, the negative values. So therefore we can go for a different activation function which is named as Lakey ReLU. We can say it is a Lakey ReLU. So what is Lakey ReLU? It is basically just saying it will take 0.01 comma y. The y is same. If the y output we getting greater than 0, we'll keep y as it is. But if we getting any value which is less than, we can say less than 0, so we are going to do y multiplied by 0.01. So here you will get one value which will provide some meaningful insight for the next layer, rather than the ReLU where it was just providing a 0 here. So in this case we are providing 0.01 multiplied by w4 plus b. So for here again the model will keep the random weight. Suppose it is providing as 0.80 and the bias value it kept as 0. So this value is getting by the model, and this is, we can say, 0. So it is providing some like calculation, we can say, like whatever value we getting into negative, it will be get calculated with 0.01. So as for this Lakey ReLU activation function, then we have a different function. Again we have the tan h, and then we have the edu. So every activation function working different. So those function will be get used as per the use cases what we have. So like, and once we go for this, like, so this is completely like a forward propagation where we are passing the inputs into the hidden layer. This is our hidden layer 1, and this hidden layer passing inputs input for the other layer, which is the output layer. So suppose if you're working on the binary classification, so we keep here as a sigmoid. right? And we'll get output into binary. Like suppose if for the binary, it will get 0 or 1. And this was the hidden layer one, where we keep the activation function. So here we have x1, x2, x3 as input. The weights we have, weights initialized randomly by the model, and here we have a w4. So and everywhere we can see, here we can see we have bias 1 here and the bias 2 here. So these weights and bias will be added by the model, but these input features are getting from our data. And simple, it will go forward, it will learn, and it will check how much loss it's making. So as if you're working on the binary classification, like for using the symbiote, on that time we use the binary cross entropy. So here we calculate the loss, right, using the the binary cross entropy matrix, and then we are seeing how much loss we are getting. Suppose we are getting loss of 54, something like 0.54. So our main is to reduce this loss, right? So we trying to get the good accuracy. So loss means how much we are making, like we can say like percentage of error we are making on the given accuracy. So we needed less loss. We're looking for to make our model prediction, so we can say the into the less loss. So to reduce the loss, we needs to update the weights. So weights we have w1 needs to get update, w2 gets to update, w3 gets to update, w4 gets to update. So for that, the model basically run back, like as it done the forward propagation, it will run back to first. So here we need to update the weights. It's basically like you have one gradient descent like this, and here you are here, suppose as a first level you got this loss, this is the loss and this is the weight, right? So here like the main is that to get on this region. So this region consists the most lowest loss for that given whole calculation. If we reach on this area, we can say we are making very much loss, like less loss on this area. So we need to update some weights, like we wanted to travel in this region, like we want to travel towards this. So we are going for some addition, where we're addition into the weights, right? And suppose if our loss getting in this region, on this slope, so this point should be get closer to this area. So what we need to do here, we simply needs to reduce the loss, reduce the weight. So for this we need to follow one formula we have, which is we can say w new. I can write here w new equal to w old minus learning rate of derivative of loss divided by derivative of w old. So we need to update this, we can say update this new weight using this formula. So here we have the learning rate, which we keep like usually 0.001. So this is helping to reach the global minima. Like if we keep as just 0.1, what happen when we plan to get slowly reach at this point of area, and when we go for this calculation, after that we might jump strongly from here to here, then here and here, and we will not able to reach the global minima slowly. So to reach the global minima very smoothly, we need to keep the learning rate as 0.001. So what happened with this, we will travel very smoothly towards the global minima, and once we reach here, we can say we are getting very much less loss. So for this, we are basically follow again the back propagation along with one chain. So that is the chain rule of derivation. So what is that? This is our inputs, this is we are passing, and here we have output 1, we can say, and here we have the output 2. So why output 1? Because from here we are applying some activation function on the given calculation of weights, and we can say onto the inputs along with the adding of bias. So here we will provide one output here, and this output 1 will be get multiplied with w4 plus bias, and will provide for the next. right? So what happened if we just make it quickly cover this one? So it is basically, let me just try to write the rule of the chain rule of derivation. So it is basically, we wanted to update weights. So we have weight 1 here, weight 2 here, and weight 3 here we have, and we have here weight 4. So we wanted to update all the weights one by one. So we need to follow first from the background, like from here. So what is basically here? So after, like when we go for the sigmoid here, sigmoid, we apply the binary classification and we'll see how much accuracy our model provided and how our model providing the output. So here basically, after this we look for the loss, right? Means how much error our model is making properly. So here basically, if you like, if I want to update the W1, so I wanted to go with the back, like from the back way. It is like, suppose I want to update the W1 new. So it's basically, I need to follow the chain rule of derivation. It is like you are saying derivative of loss, which is this one, derivative of loss divided by derivative of O2, means the loss was dependent on the O2. Then you moving forward to doing multiplication, and then you going for the O2. Now you writing derivative of O2. Now on what the derivative of O2 is dependent? It is dependent on the derivative of W4. I will write as derivative of W4. Then multiply by, now like W4 is dependent on where? It is dependent on the output one. Let's type derivative of W4 divided by derivative of output 1. Multiply by, now the output 1 is dependent on what? It is dependent on derivative of W1. Let's type derivative of O1 divided by derivative of W1. You can see in the last we able to get and work on the W1 new. The same, if you want to update for the W2, we can go with the same, and then we can set derivative of O1 by derivative of W1, like that. So this is the process of backpropagation, and so this we call as a chain, we can say chain rule of derivation. Yeah, so this is about how the forward propagation work. So the thing, when we add the inputs, right, add the inputs, add the weights, add the activation function, calculate the first layer output, moving ahead, calculating and multiplying with weight 4 and adding bias, then this output we are passing for the next output layer, which will become input for the output layer, for this one, and working towards to calculate the loss. So this becomes the forward propagation. And when we go from backward to forward to update the weights, this is called as the backward propagation, right? So this I explained, and again I went too deeper with the numerical values, how we set the numerical values and update the weights like W4, how we can update, and how it works in the real world in order to get the less loss. It means if we're getting less loss, it means we are reaching too close to the accuracy. So this was my topic in my all of the 3 classes. So today's my completely session was it's again started from 4 p.m. to 5:30 p.m. Then I reached home at 6:15. Then I had my oatmeal. It was for the protein. After that, at 7 p.m. to 8:30, I took the data science batch 2, and after at 8:45 might be, I take batch for the GenAI. So it was completely busy schedule, and I'm fully trained right now. So I just tried to finish this video and just edit the video and just post on the YouTube, and then I plan to go for bed for today. I don't know how much it will time take to make this whole thing, but I just tried to make it quick because I didn't want it to make my today's work for tomorrow's task. So I just tried to finish it as soon as possible, and I will just try to post my daily journey of how I'm working on my fitness and how I'm working on my diet, along with working in the company. Even I need to just learning, but still I just need to spend time on my desk to learn new, to teach new things to my students and make the concepts clear. So even this was my book for, like you can see. So when I am in home, I just try to write something like this. So this I written for, like for the derivation and everything. Again, my notes goes on, like just notes. So this is the life of a trainer, like needs to get prepared for the students' questions. So we should not blank when someone asks any questions out of the context. So you should be ready with the correct answer, because you can't get the students into the wrong direction. So this was for today, and we'll get back tomorrow. And keep learning, keep doing workout. And I just try to make one thing good in my video. So I just try to make the good audio, like good audio and just good editing for the viewers. And that's it. So thank you for watching this video, and get back. Thank you. Bye bye.